Hello, everybody. That was a sudden entrance, huh? Welcome to the Thursday evening session of Tech Ed. There's quite a bunch of people here. I'm pretty glad that you survived the, 3-4 Barcelona nights with such a good weather. I love this city, by the way. I mean, it's a very good city, and with the good weather, it becomes exponentially good. So, my name is Gökşin Bakır. I'll be talking about developing applications with WCF and XAML-powered WF, Workflow Foundations. I work for Microsoft Corporation. I am the developer evangelist for Middle East and Africa region. The Middle East and Africa region covering something like 76 countries, so I travel, a significant amount of time. So, today we will be talking about basically XAML, WCF, WF, and how we integrate the two. Now, first thing is XAML. XAML is a representation of our workflows in a structured way. Some might call it XAML. We'll come to that point. And that gives a substantial power to the workflow applications, so we can just have them and carry them anywhere we want. We'll look at some types of applications at this point. And then on the second part of the talk, we'll be talking about how we are going to integrate our services with our workflows. So we got workflows running around there, and we got services, and we love services. It's a very good implementation of any kind of architectural, service-oriented architectural definitions we have. But putting them together might sometimes be a task that we have to come over. So we'll be talking about that. We'll be talking about a number of ways how we can do that. So what's XAML? XAML is the extensible object markup language. It is the way we represent the workflows of Windows Workflows Foundation. It is an extension of XAML. As you know, XAML is the extensible application markup language. But at the point, XAML usually stands for the user interface part, as the Silverlight, Expression, and all the other good fancy tools we have are using XAML. XAML is sort of identified with the user interface part. And XAML defines our workflow objects. All .NET 3.0's workflows are represented in XAML. So we will see two types of workflow objects in .NET 3.0. Code separated and CLR based. If it's code separated, there will definitely be a XAML file behind it that defines it. And we will be digging into the XAML and see what kind of commands, what kind of structures we will have. The XAML format, in some ways, can be considered a part of XAML, as I said. And there might be some cases that you will see that, hey, XAML is XAML anyway, so why don't you call it, XAML, and then get rid of the problem? Not really. XAML is different. It is the object flow. It is the application logic. XAML is the application markup. So I'm definitely against the idea of XAML is obsolete. XAML is there, and it will stay as the file format for workflows. So what does it do for us? Basically, XAML enables developers and designers to develop their business models, business logic declaratively, and closes the gap in between. So when I say that, when I say designers and developers, people start thinking about, hey, designers are user interface designers, right? They design the screens and stuff. Not really. I'm talking about the designers that design the workflow inside the company. Those people are the best helpers for chief executive, chief information, chief financial officers. And they define what is the business logic in any business procedure or a corporation. It separates it from XOML separates it from lower level implementation, that is the code. So we're modeling it by some code that is compiled and some XOML representation. And this gives us the power of using any type of workflow, or even more, changing the workflow at any time by just changing the XOML file. Think it this way. You're an ISV, and a customer of you comes to you saying, hey, we want to change the workflow that you have given us. So would you do that for us? We say, yeah, sure, why not? I mean, I'll do that. It'll take me 2 days to, first of all, understand your workflow, and then do the modifications, and then I'll charge you this much. But they will say, you know, you already charged us, why do that? And then you can say, hey, you have the XOML, so you can just go ahead, use your favorite designer if you want, or go ahead and type something else and define the whole things from scratch, or do your modifications again. That gives us portability as well. Not only your customers, not only the designers can do that kind of things, you have portability using XOML workflows. Now, the dream of a service-oriented world is applications talking to each other, right? And being acquainted with each other themselves. And getting the definitions and executing the tasks themselves. XOML, representing the business logic, makes you able to realize this. So you can port one XOML, take it to some other place, and start executing it under a workflow runtime engine. You can store and transmit, or you can activate it on some application that does not even belong to you, or some application that is native to your application. In order to do that, we have to serialize and deserialize these files as well. So in order to serialize, we will be using workflow markup serializer. Now, the workflow markup serializer is primarily implemented to be worked with the designer. So when you do the serialization, you send the result to the designer, and the designer gives you a serialized representation. While we're doing this, we're going to use this fact. We'll be using a designer in our program as well on the runtime. So we will be using the workflow markup serializer and send the results to the designer, and the designer will just get what they give and put it out as a serialized format. On top of that, other than workflow markup serializer, we have the activity markup serializer. Because we have the workflow, and inside the workflow, we have activities as well. And that also works the same way, where the composite activity markup serializer is a set of activities. Serializing and deserializing will lead us to the fact that we have to do some custom definitions. So we'll be able to do some custom definitions. We will be defining our custom activities and then serialize, deserialize them as well. Then we will be seeing that we can do this declaratively as well. All these has certain format rules, but actually they don't have any certain grammar. So the way you do that depends on your favorite flavor. Now, we'll be talking about sequential markup workflows and state machine markup workflows. The simple sequential workflow is just a markup file and the code beside file. All activities are dragged in. They follow a sequential pattern, start and end. You don't have to designate what is the start point, what is the end point, because they just go from one point to another. Let's just go ahead and do a small demo about a sequential workflow. Now, what I have here is basically an empty workflow. Nothing here yet. Let's just put an if-else activity. There's my activity. We can put some code activities inside. I'm not going to fill them up. So there are some stuff that I have to fill up. I'm being told that I have to fill these out. Actually, this is how you define a workflow. In the background, on my sequential workflow.xaml file, I have the XAML source of this thing. Now, what I have added here is basically an if-else activity. Inside the if-else activity, 2 branches, and on those 2 branches, I have some code. And these code are handled with code activity 1 and code activity 2. I'm not going to use these. I will just delete it and then pull out my predefined XAML. Now, I have a few other things in here. Basically the same if-else activities, 2 branches. There's a code condition for branch 1, which says is under limit, and it's implemented in my code behind. And I have onApproved when the client is under its limit, and on rejected, that's going to be executed when the client is not under the limit. Visual Studio here gives us the politeness to render this for us. So I can approve, reject, and everything, and that XAML is graphically represented like this to me. If I check the code behind, there are 3 methods implemented: is under limit, onApproved, and onRejected. So these have been implemented before. There's no automated things behind that, and actually that was the only code written there. Now this is a workflow. In order to run this, I need some sort of a host, right? This is a console workflow application, so I'm just going to get the workflow and start running it in a, you can call it somewhat standard way. By the way, all the code I'm showing will be available on my blog. So all the examples that I have done, I'll be doing a bunch of stuff here, will be put on my blog in a couple days. So you'll be having everything that I type in here as well. Now, in order to run the workflow runtime, I need to do some synchronization in between. So I'll be using the auto reset event for the threads synchronization. Let's call that a wait handle and make it a new auto reset event and set the initial state to false. Now, I have the workflow runtime that has been defined. So my workflow runtimes, workflow completed event will have a delegate here with parameters, object, sender, and workflow completed event arguments, E. And I'm just going to implement it right here. So I don't need to write anything. All I'll do is, if it's completed, I will just do a wait handle dot set. That is completed. The only other thing that I need to handle is workflow runtime dot workflow terminated. In case there is an abortion, there's a user intervention or some error that's coming out. So again, I'm just going to add a delegate to this one as well. Object sender, workflow terminated event arguments, A. And in the implementation, I will do a couple more things. First of all, there is something going on in here, so I definitely want to know what's going on. So I'll put on the console what the story is by just saying E, inside here, of course, E.exception.message. The message comes to me as a string, luckily, so I can directly use that. And what else I have to do here? Synchronize. So wait handle dot set. So much for the housekeeping. Let's run the workflow. So let's get a workflow instance and call that instance, which will be a workflow runtime, and I'll be using create workflow. And the type of that will be sequential workflow. Okay, so I create a workflow instance, and the type of that is sequential workflow, which is my workflow that I have defined here. With that taken out of the way, we can just start the instance. Now, the instance starts here, gives us another thread. What do I have to do? Wait for that to complete. So my synchronization auto reset event here will just go wait handle that wait one. Let's see if it compiles. It does. Interesting. Usually, if it compiles the first time, there might be a serious problem with it. Whatever. So this will just run and get out of the screen. So let's just make some console.writeLine. Press a key. Some people used to press the key A when they see this message. So that's why the A key on some keyboards are very worn out. So let's go console.read key. And I think we'll be safe here. So what did we do? Let's see what we did with running this. We just approved the purchase order, nothing else. The user is under limit all the time, so the workflow will run through the approve, and then we'll just get purchase order approved. Nothing fancy here, because what we're doing is basically getting the XOML file inside our designer and then running it. This is the start. What else do we have? We can have a state machine markup sample as well. And I'll do that right now. So the difference of a state machine markup workflow is basically we have a start state and we have an end state. And in between, we can have some intermediate states so that we can just go tell our boss, hey, we're really doing something. So we can directly go from start state to end state, but that won't make a lot of sense. And then in order to designate these, we have to have an initial state name, and we have to have a completed state name. Let's go ahead and do that on another example. Let's open the state machine markup example. Now, it's the same thing. No code yet. Nothing in here. I won't just go drag, drop some stuff. I will directly go to the XOML file. No, not this one, sorry. I will open it with the source code editor, an empty text, empty state machine workflow. So I will add some state activity here. The reason I don't type these is this. We don't have any IntelliSense here yet. So, well, again, there are some nice XOML editors that we can bind into this one. But again, that's not the point. So we'll have some state activity, which is the start state. It's going to be an event-driven, and it will give us a delay of 5 minutes. Then we have a delay activity, and the code activity, when that's handled, will be code to handler. And then the final completed state. When we check it out on our state machine workflow, it's going to render us beautifully for us. So we have to do some more housekeeping here. We have a delay, some code, and then set state. So inside the code, we can just go ahead and say console.writeLine what we are doing. So we are basically in start state, moving to which state? State 1, right? Did I call that state 1? I guess I called it state 1. Then again, there's the other activity here. And it has a code to handler. Let's cheat a little bit and copy it from here. So we are in state 1, moving to completed state. We're done with the workflow. Now, how are we going to do the execution? How are we going to host? How are we going to start, implement the code? Basically, let's just get rid of this one. The same way I did before, but this time I'm not going to type it, just copy it. We have the auto reset wait handle for our thread synchronization. Then we take care of our workflow, define it, bind it, then start the workflow and wait it to run. Of course, if I don't put this, we won't be able to see what's going on. So more torture on the key A. That's right. It's taking a long time, and why is that? We have delays of 5 and 2 seconds. So from start state, we're moving to state 1, and from state 1, we're moving to a completed state. Again, not a lot. Let's move on. Now, the real part starts with serializing these activities. How do we serialize these? First of all, in order to serialize, we're going to use the workflow markup serializer. Then we're going to feed that into the designer. And from the designer, we're going to get the result and do whatever we want to do with that one. Now, at that point, we want to deserialize that one, maybe, or some other deserialized event that we just read from the disk. And in order to do that, we're just going to create a workflow. 2 little tricks here. Workflow markup serializer goes to the designer, and then the designer gives us the serialized version. Second, create workflow is just does the workflow, but you have to validate that one. Make sure that the workflow that you got is a valid workflow. Let's do that. Workflow serialization. Now, where's my workflow? Sorry. I don't have a workflow here. I only have a project called console activity, which hosts a console activity. And this is just a class that has some method to put something on the console. It's got its get and set descriptors, and that's it. And it's going to use an input string to do all of these. I'm going to do everything on the program. So in order to serialize, I'll be using a XOML file. So let's define that one first. Constant workflow runtime, workflow file name, workflow file name, is that right? Let's make that workflow.xoml. Okay. So again, using my workflow runtime, I'll do the same thing. Let's just get the initialized code from here. My wait handles and stuff, I just defined a workflow here. The only thing is that I don't have a workflow yet. So let's just create the workflow. All right, let's just tell our user that we are creating it. Console.writeLine, creating workflow. Let's define a sequential workflow activity that's going to be a generic workflow activity, and let's call that our workflow, which will be a new sequential workflow activity. Let's give it a name. Workflow.name becomes programmatic workflow. Hopefully not a problematic workflow. Workflow.description might be anything. I'll skip that one. So I'm almost ready for the workflow. I'm just going to add some activity into it. What I have here is I already have the console activity as defined above. So I'll define the console activity as activity, and it's going to be a new console activity. Okay, so we created the workflow. We're not running anything yet because we don't want to run this workflow. We want to serialize this workflow. Let's tell that we want to serialize that one. Serializing, that should be enough. So we're going to serialize actually this to a file. And how are we going to do that? We will use a workflow markup serializer. And we will call that serializer. Workflow markup serializer. Done. How are we going to do that? We'll use a XML writer. Let's call that writer. All right, it's going to be an XML writer that create. What are we going to use here? Our workflow file name. I don't have that. Where did it go? That's correct. Thanks for that. Listing to. Okay. So create workflow file name. Now I got that. What am I going to do with this? I will put that into a designer serializer manager, because this is basically done for the design time, not for this purpose. Yeah, let's do that. Designer serialization manager. Let's call that serialization manager. A new designer serialization manager. Okay, I got that one in my hand too. So let's just go use it. Using our serialization manager dot create session, which will create a session for me. I will be doing some more stuff here. I'll just serialize this. I will just go serializer dot serialize parameters. First of all, I'm just going to get the serialization manager, who is the designer serialization manager. Then the writer. Okay, am I doing it right? Yeah, and then the object. And what was the object? What was my workflow's name? It was called workflow, maybe. Right? Done. What's that? The workflow? All right. You don't miss a thing, do you? Are we safe now? Okay, so what can happen at this point? I might get some errors. Let's do some housekeeping for the errors. So it goes our serialization manager, if our serialization manager dot errors dot count is greater than 0, let's just do something. Let's just do console.writeLine. Okay, this is nice. Errors occurred. Very explanative. Have you used Silverlight? Yeah. Then go back. Did I type it right? So, in order to create the workflow, we create a workflow, add some activity to it. Actually, we did not. So we'll just go here, workflow dot activities dot add, what was my name? Activity. Okay? So far, so good. And then, so this is this. Let's just do a hold in here, and let's see if I'm right. Okay, with the help of my syntax checkers, thanks a lot, I'm done. Let's go run this. Was pretty fast, huh? So what happened here? I created a workflow and dumped it into a file. Let's see that file. Make sure I'm not lying. As if you don't trust me, but we'll see. So our markup examples, the C#, our host application goes to its running directory, and we got workflow.zoml. This is the 8 for 19. Yeah. Let's see what we have here. This is supposed to be big. Anyway, whatever. So that thing. I have my sequential workflow activity, and it contains a console activity. Now, what is it useful for me? What am I going to do with this if I don't run it? So let's go ahead and, without saving it, run this. Actually, we're going to write that once again, but deserializing will be a little easier. Console.writeLine. You know my style, right? Deserializing. Okay, so we'll create a workflow instance. Let's call that, we did use the workflow, so we can call that a deserialization, right? Yeah. Deserialized workflow. And right now, there's nothing. Okay? All right, we created that one. Deserialized workflow, be null. Let's do a try catch block. All right, so let's go. I'll use a reader, XML reader, which I'm going to call reader, will be equal to XML reader dot create workflow file name. Okay. Okay. Am I good with the syntax here? Yeah, I think so, right? Okay. Then this serialized workflow is my workflow runtime dot create workflow from the reader. What am I going to catch here? Well, there, when I do the deserialization, I get the workflow validation failed exception. I guess so. Workflow authorization, workflow validation failed exception. That's an EXP. So let's put that into a list. Validation error collection list, which is coming from my dot errors. Okay. Fine. Did you catch any errors so far? Okay. And for each of them, which are going to be validation errors. All right. For each validation error in list, let's just go console dot write line error dot error text, and again wait for it. Try catch and done. Are we okay here? Yeah. Let's go and run this. Workflow is created to the workflow.xaml file. And then using the reader, I deserialize and run it. It doesn't do anything, so, but as you see, deserializing is much easier than serializing because we directly use it. Only we have to handle some errors that are coming from the validators. So that was my console activity here. And the console activity doesn't have any workflow activity-related definitions yet. If I want to have some more custom serialization, then I can show some declarative workflow. Now, my designer serialization here will be using the workflow markup serializer and declaratively do what I did there for my activities. Again, let's show that. This is going to be faster because I'm not going to type. Because I already typed almost all of that. Okay, here I have two activities. I have a queue and a stack. Basically, a queue gets some children and gives the children out from the queue by just retrieving them on an array. The stack, on the other hand, has the same implementation. You can add some childs and then retrieve the list of the children. The only trick here is reverse the array so it acts like a stack. Are we together here on this? Fine, it's nothing to do a lot. My queue activities basically are using these serializers. However, I have a designer serializer which will serialize my queue activity through the workflow markup serializer and give me the result. And all I did for the workflow in the first example, I did here declaratively. Of course, I will do that for the workflow again. So if I check the program, I just get my workflow instance. Let's go to the top a little bit. I'm using my validator, workflow serializer, and designer serialization manager, definitely, to do the same things for the workflow itself. But for the activities, although I have to do the same thing through activity serializer, I just create the activities through a sequential workflow activity and then add them to my workflow. Here I add 3 queues, and here I add 3 items and put that on the workflow. Same thing after that, serialize to a XAML file, wait for some input so that you'll see, that if it says I have written, we have to see that one. And same thing here. So in this case, when I run, I will be getting a serialization, which is put to the XOML file, then a deserialization. Get that XOML file with the execution, and then run the XOML as a workflow. So, simple example here, but you can get this workflow to travel anywhere with this much stuff. Let's do something more. Let's start integrating these with some communication foundation services, say. And why do we want to do that? Now, first of all, what is Windows Communication Foundation? I think it is big. I think WCF is really big. And my opinion is that WPF is the only widespread WCF. Did I say WPF? Yeah, sorry about that. WCF is the only almost complete implementation of services. There's nothing else that can use queuing, distributed transaction coordination, use all kind of WS star implementations, put it in endpoints, and get things out, and give it to you in a simple way. That is the key. You can do everything, but doing it in a simple way, just saying, hey, this is my endpoint, and this is my service, publish it. It's big. And there's lots of stuff going under that. If you have been in the initial phases of writing web services, using SOAP envelopes, struggling with text files, trying to zip them, then struggling with the port 80, how to get them through, and then, you know, all kind of these, plus adding some security, adding some transaction on top of those, WCF does all this for you. It is the connector on the cloud to connect your applications. Now, WF, what do we have on the other side? WF is the application logic itself. How long do you think workflow has been on in the market? I would say more than half a century. Because everything we have been doing, I mean, including those wired programming stuff, are based on a workflow. Only the implementation, the code implementation has been more. Everything is running on a workflow. Now, the workflow we have at this context is conceptually, declaratively, or visually designing this and letting it run. So it's the same thing, basically, what we get at the end, but the tools we have are big. So why don't we just put them together? Put our application logic over there and our services, have our services nicely integrating with our workflows. It's going to be good. We have currently in our hand Visual Studio 2005, and in a couple of weeks we will have 2008. But right now, without it coming out, we don't have any out-of-the-box integration layer. Wrong. I would say in a couple of weeks we will have that one, so this really becomes obsolete. We will have out-of-the-box integration with .NET 3.5, not 3.0, but with Orcus being released, Visual Studio 2008, we will have that out-of-the-box integration. However, I'll be talking about .NET 3.0 integration and then 3.5 as well. So what kind of integration can we do here? First of all, we have to excuse me, define our workflows and services and have them know each other. We have to do this through a contract or some rather low-level definition. We have to do that one. Here, we will use a simple programming model because we will just let everything be handled in the contracts. However, for every workflow type, we will have an implementation on the other side. So if you have a workflow, it will be mapped to a service. Now, we can use auto hosting that comes out of WCF, assuming auto hosting is not a very unfamiliar concept. Now, we will have less code here, but in order to do the bindings, we will have extra endpoints because the services will reach the workflow or vice versa to the endpoints, and we have to define them all. So this is also, profits and consumptions of what we have in our hands. Finally, with 3.5, with the durable services coming out, we have two new activities called receive activity and send activity. With those two, we can easily receive some event, and depending on the external event, do whatever we want to do. And with the send activity, call an external service. Which one would I prefer? Well, definitely, if I want to do things fast, I will prefer the 3.5 implementation. But I will go through the 3.0 implementation as well because it's got a lot of features that I really want to show up. So, let me open my next example. This is called a fire workflow event. It is a complex example. It's written by Roman. Actually, the basis is written by Roman. I did a number of modifications on that one. But it defines a good bunch of samples and putting things together. It's not only about integration, it also includes some extra stuff that you might want to put into your workflows. So, to start with, let me just close these projects first. I have a workflow, library. In the library, I have 3 workflows. Let's go shortly over them. My workflow 1 is a state machine workflow. What it's going to do is basically do the initialization. It has an event-driven activity where it receives a message. On receiving the message, it will call its parent, wait for message. So it will be going in a loop. And there's a timeout. If you fall into timeout, don't touch this activity for like 5 minutes. It'll terminate. Simple. Let's go into the event-driven activity. Now, here's the trick. With the event-driven activity and the handle external event activity, I can get connected to the outside world. And how do I do that? As you remember from the slide, I do that through the contract, my interface contract. My interface type is iWorkflow. Here is my interface contract. It's not very complicated, but you need to do something. You have to decorate with external data exchange. When you do this, your activity couples event-driven activity and handle external event activities using this contract becomes visible to other applications, in our case, services. There is even more. If you add a correlation parameter, what does this bring you? This brings you the opportunity to define the workflow part in your complete workflow, where on my workflow 3, I have 2 sequence activities, and my call external method activity here implements iWorkflow events contract interface. And as you see, let me just go back to the contract for a second. My correlation parameter is task name, right? And on my workflow, as I implement that interface, I have a property called task name. And I will call that task name hello, because this is a demo, right? And do you know what I'm going to call the other one? Maybe world. So this is how I'm going to designate the difference between parts in a workflow. I have another workflow here that I'm going to use. It's called workflow 2. This doesn't have a lot of fancy stuff in it. It basically has an event-driven activity and a handle external event activity where I use this pair to implement the contract, you remember, to be able to get connected to the outside world. It doesn't do anything. No code implementation yet, but it runs through. So, done. In order to run this, I have to host them in somewhere so that I can, my client will call the host and the host will do whatever it wants to do. Now, my service host here, I think this is one of the most interesting parts of this example, has a program that's yes, of course. And here, it's got some implementation. I was asking, should I abort the transaction? Yes, no, but I just got that out. It's implementing a queue. Why do I implement a queue? Because these are long-running processes. It's always nice to have MSM queue running beside me at any time that I can use, and it doesn't cost me anything because it's there. And I don't have to implement a lot of things for this. Then, this is what I'm talking about. For every workflow out there, I'm hosting them in a host, in a service model. Here, I have one host for each workflow. Then, I have, let's just get rid of this guy, my workflow runtime. And it gets from the workflow runtime configuration. This is something that I'm going to come back very soon. And after that, I add my extensions to my hosts, do some housekeeping for printing out what is going on, and open the hosts. And wait for some events that I can service. Just get ready there and then see what I can do. Now, the workflow runtime configuration is one of the basic parts. It's in application.config. It has two sections. We have two sections here. The workflow runtime configuration and a local service configuration, which will define our service endpoints as well. Now, in the workflow runtime configuration, I have the external data exchange service. And what is that used for? To communicate with the workflow and the services. Okay? Wait, it's going to get more complicated. Or excited, which one you want to call. Now, these two services, SQL Workflow Persistent Service and SQL Tracking Service, are very, very handy and useful services. What do they do? SQL Workflow Persistent Service handles your workflow. Your workflow is initially in the memory, right? But assume you have a long-running transaction, say 2 weeks. And after 2 weeks, you just go say, hey, you're done, you're finished, you're approved. What happens if you cannot find that workflow running over there? It's not in memory. The machine that has been hosting that is gone. What do you lose at that moment? First of all, you lose your workflow, that running instance, right? Then you lose your past. You don't know where you were. I mean, the client will not say, I got an error, when the workflow was doing a bank transaction just before the dispatch event. It's going to just call you, your program is not running anymore. It's just giving an error. And you say, what error? It says, I don't know. And you should have something there. If you use persistent service, SQL persistent service, it comes out of the box. You just define it here and on the client. And when you run it, your workflow is persisted into the database, which is here on this example, of course. Okay, long string, workflow persistence store. This is the database that I created. It comes with .NET 3.0. It has its own scripts, creating the database and putting some database objects into the database. And a similar thing for tracking services. If you include SQL tracking service for your workflows, everything that your workflow does is tracked. And even more, you can intercept and then get something out. This is very good for programming, for debugging purposes and following out what's going on. So we are going to use it for this purpose. But other than that, everything is going to be inside the tracking store. So you can just go after a while, check the store, and find out what has been going wrong with your workflow. And these also bring us scalability. You can take one workflow by SQL persistent service and take it out to another machine and start running over there. With that, also we can have some load balancing. So this doesn't really cost you a lot, code-wise. You just write that down in a declaration and then use it. Now, I also have a logger service here, which I integrated. I'm not going into that one. I use the logger service in order to get the SOAP envelope and print it on the screen. So when we run that, the logger service will intervene and do that. One last thing that I want to show you in the application configuration section is the endpoints. As I told you, using this method, you have to define the endpoints for services. These are endpoints for our hosts, actually. So I have two endpoints, one for the simple binding, the other for the other binding that has a correlation parameter. And I have a very interesting binding here, which is a .NET MSM binding. So I will be using the queue actively here. My applications, the console application 1 and 2, are for testing this service. So if I go to program, I have a tester. I will persist my workflow, create it. Here I won't use any deserializing. I do an unload. Why on earth do I want to do an unload here? It's actually unloading my workflow from the memory and putting it into the database. But it stays. It doesn't evaporate, okay? So the unload statement is sort of confusing. It doesn't go away. It stays there. It's unloaded from memory, so I can reach it anytime I want. Then, using my channel factory, I just create a channel for this and run my workflow. I place the loop so I can run the workflow over and over again. So let's go ahead and test it. If I run my main program as service host, I placed a number of breakpoints because the service and the client will be interacting with each other. And when I run, I open my host. The host is open, and it waits for a service, a client to ask something to it. Let's just get this to the side a little bit, and then try to get some space for us so we can see what's going on. Now, that done, let's get our console application running. We'll just say debug, start new instance. Again, it is starting. I will just run this. So it has created a workflow instance as we have seen there. There's not a lot of fancy stuff over there. It has created an instance of the workflow 1 workflow. So it's creating a state machine workflow, which will time out in 5 minutes if I don't do anything. And here is my logger. My logger intercepts the SOAP message. This message is coming from the client. So as you see, the client here has a SOAP message of workflow 1, which it has created, being sent to this service host. Now, my interceptor here received a request, which means it has intercepted the service. This is coming from the service right now. It has loaded, started, waiting for the message. The event has been received, and done. So one application calling another and doing a communication so that my client is calling the service, and the service is calling the workflow, and the workflow sending something back to the service. Let's do some more on my console application. Now, my console application here fires 2 events. You remember the workflow that has 2 parts, hello world? We're going to fire them one by one. We're going to fire this workflow, just giving it the name, and we will fire only the part that we want to execute. So we will do the same things, so I don't go in detail in those. Then, on my channel event factory, I will set my event arguments task name to be hello, and then use the reject method to fire it, which is not on the workflow, but on the service. Same thing in here. Then I'm going to fire world. How many SOAP messages will I get? Are they going to be done in a single SOAP message, or will I get 2 different SOAP messages? 2. Because I'm going to do the firing 2 times. Let's run, and follow that. Now the trace comes in. Trace is the tracing service that I have defined. I'm just getting this. Firing the event. We are sending the first SOAP. So this is hello. I sent hello. Now I'm sending the second one, which is world. I have received one of them. Now on the service host, I haven't received anything yet. Of course I received, but I'm just pausing the program. I have received something. Didn't handle anything with that one. So let's go ahead and do. So I have received hello and world, and did the initialization for that. World is received, and the first workflow, which is the hello, is completed. including the second one, which is the world. So the world is completed here, and the hello is completed in here. And I have two SOAP messages. I'm calling a single workflow from a WCF service, but I can tell which part I'm calling. Last example, on my console application 2, I will run this step by step. Actually, I will go ahead and close my service. So what's going to happen here? Now I'm using a queue. I'm using MSM queue. So I'm creating the queue. If it's there, fine. I'm creating my runtime. Let's just make this a little bigger so that it'll be more comfortable. I'm using a transaction scope, so I'm running this in the distributed transaction coordinator scope. And then I'm using an XML reader to deserialize the workflow that I have on disk, that I have defined. That's workflow 2. And then run it. Send it out, send the request, and it's gone. It's in the queue. To show that it's working, let's start the service host. And let's let it go. Receiving the message that has been sent, which stands in the queue, and does the housekeeping and execution. So it can run this anytime it can do it. Completely disconnected workflow and services here. Now, this is with .NET 3.0. What if I do a .NET 3.5 application? Let me just quickly go through that. Here we see on our workflow that we have a place order and a save order. Those place order and save orders are actually Windows Workflow Foundation 3.5 activities. And they can easily bind to a service. Here, I'm giving you a code example for something called Dinner Now. Now, Dinner Now is a very good example. It's a Microsoft example. It's much bigger than this one. It includes WCF, WF, card spaces, WPF, anything you can think about. But this one is a more compact one, so starting with this will be much easier. It gets an order and saves this order into the disk. This is not complete. The other example, a more complete version of this communication, includes two workflows. Now, the first workflow is my process order workflow, the one that you have seen the starting of. You receive an order, save it. After the order is received, send it to some restaurant and tell the client that the order has been received, and just keep watching what's going on. Now, the other order, the order state workflow, is the order itself. So it's waiting for the order state to come from an ordering company. As soon as it comes in, goes to an order open state. If it's cooked, goes to order cooked state, and then order completed. So I'll be hosting them on a console host, and this time I don't have any tracing, tracking, logging. So let's just run it. It comes out with the endpoints that I have defined. And then I have a window client. I'm working on the WPF client. It's not ready yet. And start this instance. So let's put an order amount of 12. Goes into the service, doesn't say anything because it's not printing them out. I have my order here on the order open state. I can proceed that to the next step. Actually, I pressed twice on the place order. Give it a second, it will move to order cooked. It's moved to order cooked state. The ones on the back can ask the ones in the front, they can see it. And then if I move it from cooked to delivered, it's going to be gone. So we have two workflows, a service hosting them and doing the flow. So what have we achieved here? We have basically talked about integrating these workflows. First of all, did these things on .NET 3.0. But while doing these, we stored workflows in XOML files. So we were able to take them from any place to another place. Now, one thing I don't like about this is we should have any generic workflow to be running anywhere. But that's not a workflow WCF problem. It's an SSDL problem. And it will be a completely done thing. Because, you know, in all our examples, the service, client, and the workflow know about each other. There's a common interface that they share. In a world of complete, free running services, these should be defined in runtime, and programs should be aware of each other and say, hey, you're doing good, give it to me. Hey, you know, your cost is low. I'm going to use this one, and then get the client's order ready. What we have seen on the last example, send activity and receive activity, are coming with Orcas. That part with the durable services is called Silver. Now, where we can use these is basically, there are lots of opportunities here. SharePoint, in the next version, will be coming with workflow, we'll be using workflow entities. And the designer and everything will be the same. Dynamics, implement workflow in the enterprise anyway. Speech server, when you do, you know, phone banking and other stuff, the workflow is there to direct and execute the commands in the speech server. Operation manager will use workflow to improve help desk support. And the Microsoft Integration Server this is a plan that it might be using the workflow to implement the synchronization of multiple directories. So, some resources here. You can download the code from my blog. I'll put them in a couple days, I suppose. DinnerNow.net is the next version of the example that I have given to you. The workflow, file workflow event is the on-code project, and the rest is standard references. Complete your, please, evaluation forms, and you can get this beautiful HTC Touch. So if you like the session, go ahead and complete it. If you don't bother. Thank you very much. I hope you liked it. I hope you can get something out of it. Thanks a lot.